Welcome back. Let us learn how to draw ILD for shear force. So consider a simply supported girder. Left support A, right support B. Span L. Now let us say I am interested in plotting ILD for shear force at section C. So section is located at a distance of small a. Okay? Yeah. Now divide the region or the span of the girder into two regions. AC is one region and BC is another region. So let us assume that a unit load is traveling from A to B. So when the unit load is in the region AC, so let us locate the unit load is at a distance x from A. Okay. Right. Now I would like to calculate what is the shear force at C. So by definition, shear force at C is sum of all forces to the left or to the right. So I go by sum of all forces to the right because left hand side you have two forces. So now shear force at C is nothing but sum of all forces to the right, which is only one force you have RB, and right upward force is negative. Okay. Now let us position the unit load at different locations. Say for example, when x is equal to 0, unit load will be placed at A. So in that case, shear force at C is equal to, now you can see here, this is a reaction at B, which we already wrote in the previous the lectures, what we have discussed. So it will be x by L. Okay. So you may just go through the previous video lectures for how you write x by L for a reaction at B. So now if you substitute x is 0 here, shear force at C will become 0. Then when the unit load is reaching C, the x will become A. So in that case, shear force at C is equal to minus A by L. Okay. Right. So now you can observe that when unit load is moving from A to C, the shear force values are changing from 0 to minus A by L. So let us plot the diagram. So having a reference line, first have a reference line. Now drop point C onto this reference line. So now you can see this value is 0 here, and it is a negative value, so the value here is A by L. Okay. Now coming to portion BC let me draw this case separately so that we will not have clumsiness. Section C, girder AB. Now the load position is between C and B, anywhere. Okay. And again, the unit load is located at a distance x, okay, from A, right, and section is located at A distance. Now I would like to calculate again the shear force at C. So shear force at C is equal to, by definition, sum of all forces to the right of the section or to the left of the section. So to the right, if you go, you have two forces. One is RB, other one is unit load. Right. So I go by sum of all forces to the left, which I have RA. So this is RA. And by sign convention, left upward force is positive. And RA value we have discussed in the previous sessions. It is L minus X by L. Okay. Right. Now, by positioning the load from C to B, we can complete the remaining diagram. So, when unit load is at section C, X will become A. So, when X is equal to A, shear force at C will be L minus A by L. Okay. When unit load reach support B, X will become L. Okay. So when unit load reach support B, X will be L. In that case, shear force at the section C will be, when you substitute X is equal to L, L minus L, 0. Okay, so now if you can plot those values. So this is the value here, and it will reach to 0. Okay. So now this is the diagram, which is positive values here, negative values here, and this value is L minus A by L. Okay, so this value is L minus A by L, whereas this value is A by L. Okay, so when the unit load starts from A and approaching section C, the values of shear force at C start from 0 and reach maximum negative value, which is A by L. It is maximum negative shear force. Once the unit load cross section C and go away from section C and reach B, the value is jumping from A by L to L minus A by L, from negative to positive, sudden jump, and slowly reducing to 0. Okay, so L minus A by L is the maximum positive shear force that can happen at a section. Right? So when a unit load moves from A to B, the shear force values vary from 0 to maximum negative and suddenly jumping to maximum positive, slowly reducing to 0. So this is what will happen when unit load pass from A to B, and when you are interested at a particular section shear force values. So they look like this. So this will be the ILD for shear force. Okay, and if you can see this, if you can extend this, so this is nothing but ILD of RB. And even if you can extend this line, this is nothing but ILD of RA. So a part of ILD of RB, a part of ILD of RA will be put together. It is ILD for shear force. Okay. Right. Thank you. Meet you in the next lecture.